Welcome to Fabric Monday. Today I'll talk about saving money with the right type of notebook. There are many types of notebooks, there are many flavors of notebooks. Each kind of notebook has a different cost and is the ideal notebook for specific situations. Let's analyze more about this. The multiple notebook flavors. What are the kinds of notebooks that we have? We have the T-SQL notebook, we have the Python notebook, the PySpark using native execution engine notebook, and the PySpark without using native execution engine. The native execution engine, a recent new feature, makes a difference according if it is enabled or disabled in a PySpark notebook, resulting in a total of 4 types of notebook. The core secret about the decisions that we need to make is about if and where we are using a cluster for data processing. If our amount of data is too big, too huge, we may need a cluster for data processing, or otherwise we may not need a cluster for data processing. If and where we are using a cluster is a decision point about the kind of notebook that we should use. Let's talk about data sources and clusters. Data sources, I'm talking about the lakehouses and data warehouses. Lakehouse SQL endpoint, and mind that I'm talking about the SQL endpoint of a lakehouse. When we access a lakehouse SQL endpoint, when we send a SQL query to a lakehouse SQL endpoint, a Spark cluster is used to process the SQL query. And this Spark cluster can scale. If the SQL query is too heavy, this Spark cluster will scale in many servers to process our SQL query. In the case of the warehouse, there is an architecture called Polaris. The architecture Polaris generates a cluster to achieve the same result. So, both of them use different architectures. One uses Spark, the other uses Polaris. But the main point about this is that when a SQL query arrives to these elements, either a lakehouse SQL endpoint or a warehouse, a cluster will be used to scale out these queries. Then we can conclude any query to a warehouse or lakehouse SQL endpoint already have a cluster to retrieve the data. Now let's talk about the relation between notebooks and clusters. First, the T-SQL notebook. The T-SQL notebook is intended to be a client to be used over a SQL endpoint or a warehouse. As a client, it has no cost and no cluster. It doesn't create a cluster and it generates zero cost on the capacity, in fact. A Python notebook uses a single server. It doesn't use a cluster. It uses one single server with 2 cores. 2 cores is smaller than the smallest server that a Spark cluster can have, which has 4 cores. So a Python notebook uses a small server to make the processing. A PySpark notebook without using native execution engine uses a scalable Spark cluster. With a native execution engine, what happens? The PySpark notebook can use the Spark cluster, but the native execution engine gives to the PySpark notebook the power to bypass the cluster and go directly to the one lake to make the execution of the query. So, the native execution engine gives the PySpark the power to bypass the cluster for simple queries, not for complex queries, only for simple queries. Considering all this, what's the decision question we need to make to save money? After considering all the SQL operations, how much data will be processed between the SQL operations? According to the processing we are making, we may be executing many SQL operations, but Sometimes we may need some processing between the SQL operations. Get the result of one, process something and execute the second one, process something, and so on, or not. So the question that we need to make to analyze which kind of notebook we will use is how much data we'll be processing between the SQL operations over these endpoints. And the answer tells us what to use. If we have no processing between the operations, use T-SQL. Use a T-SQL notebook, because in this kind we have no cost coming from the notebook. The cost will be only on the data source, SQL endpoint or data warehouse. The notebook will have no cost. If there is more processing between the SQL operations, in this case you can use a Python notebook. So this is the smallest cost that you have, which still allows you to make some processing between the SQL operations. But if you have a heavy, simple processing, in this case you want to use PySpark with native execution engine enabled. So you may need the cluster, but for simple queries, you allow the PySpark to bypass the cluster, process the huge amount of data on the cluster, but when executing the query itself, it doesn't execute on the cluster. It bypasses the cluster and goes directly to the one lake. For heavy, complex processing, you would like the native execution engine disabled, because in this case the native execution engine will have no benefit, because it's not capable to support complex operations. Complex operations, I'm talking about complex grouping, complex window operations in SQL and so on. This kind of complex operations the native execution engine is not capable to support. Let's analyze this visually. I'm showing a cluster. A cluster which can be a SQL endpoint in a lakehouse or a warehouse. It doesn't matter. Then, we can access this cluster by a T-SQL notebook. The T-SQL notebook is only a client. So the T-SQL notebook goes to the endpoint, to the data source, without generating any cost. The cost will be only the cost of the data source. If we use a Python notebook, the Python notebook generates a server for processing. In this case, we have the cost of the server. We have the cost of the server plus the cost of the cluster in the data source. If we use a PySpark notebook without native execution engine, in this case, the PySpark notebook is generating a cluster to process the data. And this cluster to process the data will be making calls and queries to the cluster, to the data source. There are very few scenarios where this actually makes sense. But if we use PySpark notebook with native execution engine, then we have the cluster for the PySpark notebook. This means that between the queries, the PySpark notebook has an entire cluster to process the result of the query and ensures a good performance on the processing. But when executing the query to the data source, the PySpark notebook bypasses the cluster, going directly to the data on one lake using the native execution engine. In this case, we save money. We are saving money according to the least resources we use. Check this. This is the result in Fabric chargeback app, showing the costs of the execution. The T-SQL notebook doesn't even appear because it has no cost. A PySpark notebook without using native execution engine is the heaviest, 162 CUs. Using native execution engine, it goes down to 153 CUs. But if I'm using a Python notebook, it goes to 64. less than half. So we can go from 0 to 162 depending on the operations we want to execute. In this way, we are seeing that it is very important to choose the right type of notebook for each kind of operation, because this will affect the consumption of your capacities. But it's important to understand that we are talking about SQL endpoints and warehouses. This doesn't count when we are considering a notebook processing a lakehouse. In this case, the considerations are different. A notebook processing a lakehouse doesn't use two clusters as the image was showing before. It uses only one cluster to process the lakehouse. The point is, do you need the cluster? It becomes a decision between using the PySpark notebook, or if you think your processing is very light, use a Python notebook. You can still reduce your cost using a Python notebook. Now let's talk about some secrets about these notebook types. Each one of these notebook types has some secrets. Let's talk about that. The T-SQL notebook. The T-SQL notebook requires to be in the same workspace as your data. It's a limitation that Fabric still has. Put the T-SQL notebook in the same workspace as your data. But an advantage is that it can be used to make source control of T-SQL code. In the lakehouse and in the warehouse as well, you have those queries areas in your lakehouse. But those queries areas can become a mess, and that's never saved in source control. So the T-SQL notebooks can replace those queries areas by using T-SQL notebooks and saving the T-SQL notebooks in source control. I wrote an article about this, you can see here at my site. Python notebooks. Python notebooks obviously don't use the Spark variable. When you use a PySpark notebook, we have a Spark variable. And the Spark variable makes everything easier for us. We can make many tasks just using that Spark variable. Python notebooks don't have that Spark variable. You don't have a Spark session. You are not using Spark. In this case, you need to use another framework, a different framework. For example, you can use pandas. You can use pandas to process your lakehouse. And this is not a problem. In some cases, it may be a benefit. The lakehouse is mounted. When you define the full lakehouse of the Python notebook, the lakehouse is mounted. But the lakehouse is only understand using the full path from the root. I mean, usually, using the Spark variable, we can just use the root files or root tables, and it understands the path. In the Python notebooks, it doesn't. You need to use the full path. Root, lakehouses, the full, and files or tables. You need to use the full path. And drag and drop builds a completely different code. Drag and drop in a Python notebook use the delta libraries. The libraries used to manipulate delta tables. And using the delta libraries, it used the full address of the lakehouse in the one lake. Native execution engine, the secret that we have at the moment related to native execution engine is that it may become the default. At the moment, there are more reasons to keep the native execution engine always enabled than to disable it. But there are some situations where we may need the native execution engine disabled. However, this default about the native execution engine may change soon. Thank you very much for watching, and see you next week.